Good morning, students. Uh, Today I would like to discuss chapter number 3, most frequently asked questions in 1 mark and 2 marks from time series concept. So let us start without wasting much time. See here, some list of questions I have given here which are most frequently asked in the previous years. Question number 1, define time series, right? So this time series definition has been given by many statisticians, physicians, mathematicians, like that. Generally what we used to write the definition of time series. Time series contains a statistical data which is arranged chronologically, right? The data which is arranged, the time series data which is arranged chronologically, right? That meaning chronologically means according to time points, arrangement, the statistical data. That definition we call it as a time series. The data which consists the time series which consists a statistical data arranged chronologically, that itself is called as a time series. That is question number 1. Next, question number 2, what is a histogram? Generally we have heard about the histogram, right, which is a graphical representation. In the P1 we have learned. Here it is histogram. What does it mean? The time series data which is arranged graphically. So graphically if you represent the data of time series, that itself is called as a histogram, right? A graphical representation of time series data called as histogram. That is a next definition. Next, definition number 3, which variation is predictable and unpredictable? What do you mean by like predictable? Means like guessing, future estimating, right? We can immediately guess that what is going to be happened, how the variation would occur. So in the initial days itself, if you estimate the future by seeing the past behaviors, then we can predict such kind of variations. Which kind of variations having that predictable kind of thing and unpredictable kind of thing is generally seasonal variation. We can say seasonal variation is a predictable variation. And when do we say that it is unpredictable variation? In case of irregular variation, remember. So in case of seasonal variation, we can predict the future, and in case of irregular variation or nothing but random fluctuations, we can say it is unpredictable variation, right? Seasonal variation means, as you all know that within 1 year it comes and go, right? At the same time it's a regular, short term and a periodic variation. At the same time we can guess and we can estimate what kind of variation is going to occur in so and so season well in advance. For example, during rainy season the sales of raincoat definitely it will be in an increasing order, right? In an increasing movement, isn't it? That is what the estimating the future, isn't it? So which variation is predictable? Whenever it is asked, you must write seasonal variation. Which variation is unpredictable? If it is asked, you must write irregular variation. Are you clear? Next, question number 4, definitions of components of time series. Generally we have 4 components. First one is a secular trend, second one is a seasonal variation, third one is cyclical variation, and the fourth one is irregular or random fluctuations or variations, isn't it? Now first one, secular trend. What do you mean by a secular trend? So the trend gives the tendencies varying increasing or decreasing or remains constant over a long period of time. I repeat once again, it gives the tendency that either in increasing order or decreasing order or remains a constant for over a long period of time. We call it as a secular trend. For example, secular trend example, what it is? If you see the population of India, since from many past census years, the population is totally in a upward direction. It is in an increasing order, as well as the gold rates, that is also increasing order, right? Death rate has come down due to implementation of medical facilities. So that variation has totally fallen down, isn't it? Those are all the examples of secular variation or secular trend. Next one is a seasonal variation. Seasonal variation is a regular, periodic, and it's a short-term variation, right, which occurs to be within 1 year. And definitely this seasonal variation is totally predictable. Remember, it is totally predictable variation. So we can predict in which season what is going to be happen, right? Whether the sales increasing or decreasing, or else usage will be increasing or decreasing depending upon the season. Well in advance we can estimate, Next one is a cyclical variation. What do you mean by cyclical variation? Generally, cyclical variation is an oscillatory variation which happens to be in 4 stages. Stage number 1, what it is? Prosperity, just increasing. Stage number 2, recession. Stage number 3, depression. Stage number 4, recovery. Right? So these are the 4 cyclical stages. We can call it as a business cycle also. This one, using these 4 stages: prosperity, recession, depression, as well as recovery. Isn't it? These are the 4 kinds of variations which happens in a cyclical variation within 3 to 10 years. Isn't it? Next one is an irregular variation. The name itself says that it is not regular. Sudden and unexpected variations, we call it as a irregular variations, right? For example, see, corona, due to pandemic, suddenly it has started and death rate has increased, right? And then totally the commodity items, prices of the commodities were totally increased. Indian economy has totally fallen down. Bank rates are fallen down. See, such a big variation, such variations we call it as a irregular variation. Sudden and unexpected variations, we call it as a irregular variation. For example, war, droughts, floods, now corona, pandemic. So all these are called as a sudden and unexpected variations. During these variations, suddenly the death rates or anything will be going higher than the regular one or lower than the regular one. Clear? So that is the irregular variation. Next, causes of seasonal, cyclical and irregular variation. For seasonal variation, as you all know that it's a short term, periodic and regular variation, right, which falls within 1 year. Now, seasonal variation causes generally are traditions, habits, customs, climate conditions, weather conditions. All these are the causes of seasonal variation. Next, cyclical variation means, as you all know that the business cycle, 4 stages. Those are only the causes of cyclical variation: prosperity, recession, depression and recovery, right? And the middle one is always a normal period. So, and you know the business cycle also, the diagram. So this is the business cycle: prosperity, recession and total depression and the recovery from the past. Clear? Next, irregular variation causes. What are those? Floods, droughts, wars, earthquakes, strikes, and then now pandemic. So all these are the causes of irregular variation, where the rise or fall will happen suddenly than the regular one, increasing higher or decreasing full deeper, isn't it? So those are the causes of cyclical, irregular and seasonal variations. Next, coming to the business cycle, as I have drawn here, look at here. This is prosperity, recession, depression and recovery. These are the 4 stages of cyclical variation. Next, normal equations of fitting a straight line, fitting a quadratic equation and fitting an exponential equations. As you all know that normal equations, here summation y equals to NA plus D summation x, summation xy equals to A summation x plus B summation x square. By solving these 2 equations, we can estimate the constants A and B, right? And then we can estimate the future also by using the straight line equation. Next, coming to quadratic equation, summation y equals to NA plus B summation x plus C summation x square, summation xy equals to A summation x plus B summation x square plus C summation x cube, summation x square y equals to A summation x square plus B summation x cube plus C summation x power 4. These are the normal equations of quadratic equation, right? Next, coming to exponential. See, this exponential, we can call it as a logarithmic trend also. What are this one? Summation log y equals to normal equations n into log a plus log b summation x. Here x log y equals to log a summation x plus log b summation x square. So these are the normal equations. Normal equations writing also, most of the times they have asked for 1 mark and 2 mark. Normal equations of straight line, normal equations of quadratic equation and normal equations of exponential equations also. Next, methods of measuring trend. So we have totally 4 methods to measure the trend. Number 1, graphical representation or graphical method. Number 2, semi-averages method. Number 3, moving averages method. Number 4, method of least squares, right? So these are the 4 methods. So sometimes they may ask to write all the 4 or write any 2, right? First one is a graphical method, which is in a graphical representation just by taking x-axis, y-axis, plotting the original values, joining them by straight line, and drawing one objective kind of this one, and it is totally what I can say, like there is no biasedness. If you draw a line, everybody will get different one, right? Next, there is a biasedness in graphical method. Biasedness in the sense, according to your interest, you can draw a line in between where the points should fall up and down, exactly in the same variation, the normal line. And second one is a semi-averages method. Semi-averages method means the data which is being divided into 2 halves and calculating the trend values by calculating the averages, isn't it? Total as well as averages. If at all odd in number, the middlemost should be left out. And next method is method of moving averages. Method of moving averages, we have 3, 4 and 5 yearly moving averages, right? And the last one is a method of least squares. Generally what we are estimating in time series, what exactly we are calculating in time series is, we wanted to estimate the future by observing the past behaviors. Usually for more economists as well as the business people, this time series concept is very much useful. Because generally any businessman would think about the future, his profits and sales, right? So no businessman would think about any loss, or no businessman or no economist should think about loss. Clear? So definitely for the profit and for the benefits only, most of the people will be observing it. Clear? Next, for estimating the future. If you know the future, I mean in terms of business activities, in terms of economical activities, if you know the future, so present we can plan properly accordingly. Right? Generally, how we would come to know the future? By seeing the past behavior. Clear? So from the past behavior, what all variations occur. That is the reason we are arranging chronologically the past time series data. Are you clear why we are arranging chronologically? Because from the past years, if you observe it chronologically, then in which year it shouldn't be like any irregular variation. If at all any irregular variation occurs, again that period should not be considered. Definitely whenever you select any time period, those are to be economically stable period, remember. And the last one, ninth one, which indices are used for measuring seasonal variation? Definitely you can write it as seasonal variation, right? So seasonal variations or seasonal indices are used for measuring seasonal variation. And the last one is uses of time series. Definitely one of the major uses, by using time series concept, observing the past behaviors, we can estimate the future. Remember, future can be estimated by observing the past values or past behaviors, which is arranged in a chronological order. At the same time, it helps in planning and forecasting the business activities. At the same time, it evaluates the progress in any field of economical activities. So any field of economical activities, definitely this time series may help you to evaluate. At the same time, it helps in planning and forecasting the future by observing the past behavior, right? So past behavior observation, future can be estimated easily. And the next one is it helps in comparing the data easily, right? So from one period to another period, the time series data, if you arrange in a chronological order, easily it can be observed. So these are all the concepts of time series chapter. So which are most frequently asked questions since from 2015 to 2020. Most frequently asked questions. So kindly follow all these questions. So coming to the next chapter, interpolation and extrapolation, most frequently asked questions in the previous years. Question number 1, define interpolation and extrapolation. See, definition of interpolation already we have learnt in PU1. The same thing we are going to continue even in the second PUCs, except the Newton's advancing difference method. Clear? Now, interpolation definition. Interpolation means estimating the unknown value of dependent variable y to the known value of independent variable x within the range, called as interpolation, right? So estimating one unknown value of dependent variable which is y and to the known value of independent variable which is x within the range from x to xn, x0 to xn, within the range. If we estimate, that itself is a interpolation. Extrapolation means estimating the unknown value of dependent variable y to the known value of independent variable x outside the range, that itself called as an extrapolation. See, one is within the range, another one is outside the range. Say one for example, x0, x1 and so on xn, y0, y1 and so on yn. Right? Estimating the dependent variable, y is a dependent variable, right? And estimating the unknown value anywhere in between the missing value, estimating the unknown value within the range from x to xn, from x0 to xn, that we call it as a interpolation. If it is outside the range, if you are estimating, that itself is a extrapolation. Clear? Once again I repeat, estimating the unknown value of dependent variable to the known value of independent variable x within the range, we call it as a interpolation. Extrapolation means estimating the unknown value of y, I mean dependent variable y, to the known value of independent variable x outside the range, that itself called as a extrapolation. Now, what are the assumptions of interpolation and extrapolation? What are the assumptions? So assumptions are nothing but generally limitations, we can say. First limitation is there should not be any sudden jump in the dependent variable y from one period to another period. Sudden jump it shouldn't be. Second one is there is no two consecutive missing values. So definitely you are estimating the missing value, one is inter or one is extra. And whenever interpolation you are calculating or extrapolation you are calculating, definitely no consecutive back-to-back missing shouldn't be. Remember, right? There must be a one value in between inter and extrapolating estimating value. Clear? So no consecutive missing should be followed. Another thing is there must be a third assumption. There must be a sort of uniformity has to be maintained in the dependent variable y from one to another period. Right? In the dependent variable, sort of uniformity in the sense either rising or falling it should be, ups and downs shouldn't be, even after estimating the missing value. Clear? So these are the three assumptions of interpolation and extrapolation. Next one is methods of interpolation and extrapolation. Generally we have two methods. One is binomial expansion method. Second one is Newton's advancing difference method. So these are the two methods which we have in interpolation and extrapolation, methods of estimating I and E. Next one is expansion, y minus 1 whole power n. As you all know that the Pascal's triangle, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So this way the Pascal's triangle you know. By using this Pascal's triangle, easily we can expand this form, right? In place of n, it can be like 2, 3, 4, 5, 6, 7, n number, whatever it is. By using the Pascal's triangle, we can expand this form, y minus 1 whole power n. You know that expansion, how to do. For example, here it is 4, y minus 1 whole power 4, which is the fourth line at n equals to 4 in Pascal's triangle. 1, 4, 6, 4, 1. So apply y4, y3, y2, y1, y0. Plus minus, plus minus, plus equated to 0. So this is the expansion of y minus 1 whole power of n by using Pascal's triangle, right? Next. Yes, coming to the last one, conditions which is to be applied in binomial expansion method as well as Newton's advancing difference method. In binomial expansion method, what we need to observe? There must be a common difference in the independent variable x. Common difference must be there in the independent variable x, right? From one value to other value, there must be a common difference. That is condition number 1. Condition number 2, the missing value of y must be a missing value of particularly to the independent variable x, right? Suppose y3 is missing, exactly the missing of y3 must be a value of x3. There should not be any sudden jump, remember. So for y3 we cannot observe from x4 or x5. y3 missing means exactly x3 only should be observed, the known value of x, isn't it? This is condition number 2. So using these two conditions, binomial expansion can be observed, and missing values are clearly shown in the table, right? Either inter or extrapolating or together. Next one is Newton's advancing difference method. Here also condition number 1 satisfies the same. Like there must be a common difference in the independent variable x. Second one is like binomial expansion, the missing of y must be a value of x. Like that in binomial expansion, it need not be applied in Newton's method, right? Missing value will not be shown in the table, all the values will be known. And in the question, in the statement, it will be asked the missing value of so and so, right? So binomial expansion, clearly the missing will be shown. The missing of y must be a value of x. It will be shown. But where in Newton's method, it won't be. It need not, right? That is a condition. And one common condition is, as you all know, that common difference in independent variable x. So with this, the chapter Interpolation and Extrapolation, frequently asked questions in the previous years, both the time series as well as interpolation and extrapolation, both I could complete now. So in the next video, I am going to start the last chapter, theoretical distributions, which is very important for 1 mark and 2 mark questions. See guys, first 4 chapters are thoroughly you practice, all 1 mark and 2 marks, but unless and until you prepare theoretical distribution, it is highly difficult to score triple decimal. Remember, so we have to aim for the higher always. Clear? So when we keep our target at 100, then only we will try to reach that. Am I clear? So let us try for reaching that level, scoring triple decimal. That is our ambition and our intention, to revise these many times and to send videos these many from chapter wise, 1 mark, 2 mark, 5 mark, 10 mark, as well as frequently asked in the previous years model papers. So many ways we are finding to get you in practice with and touch with in statistics subject and to score higher also. So I hope we are clear about all the concepts. So we request all the students to observe the videos, do not waste the time, right, and do not go out and just get it affected. I hope everybody is safe at home. Stay home, stay safe. Keep watching the videos. Thank you. Have a nice day.